Hello all. Today we are going to look at an important concept that is introduced as part of JDK 8, that is streams. So if you can look at the screen, streams is quite a bit bigger concept. So we are going to split this into two sections. One is the theoretical one, where I'll be explaining how streams work theoretically, and the other one is the practical one. So I'll be using the practical way of showing how the streams work. Okay, so here if we look at right, so streams are basically is a normal stream of data. Okay, so wherein we can just this is nothing but a strict sequence of elements which can be extracted from a data store. Okay, from a collections data similar to collections data store, and then we can create a stream out of it. Okay, and we can write transformation functions on those streams and implement them. Okay, so that if we want to do some specific operations, we can perform those operations. Okay, so normally traditionally, whenever we have to work on some list of items, or a set of items or a grouping of items, we normally loop through them in the for loop. Okay, and then we will implement our code on that. Right, now when it comes to the streams, right, streams gives us a feature where we can attach multiple transformation functions on the stream of data. For example, if we have to write if we have to filter some data and transform the data based on the filters in a few scenarios, right, and then create an end list out of it, then we have to write huge piece of code for all that to happen. Now, however, if we are using streams, we can use the operations that we can perform on the stream of data. Okay, and then create an external list, final list based on the source of data. Okay, so that's where streams are very useful. Okay, and user friendly. Along with that, even from the viewability perspective as well, viewability and maintainability perspective as well, it is great. It's good. Okay, now this sequence of elements, these streams is different from the normal IO streams that we have in in JDK till JDK 7. Okay, those are IO streams, and this is the stream of data. Okay, stream collection streams to just give a reference. Okay, so here if we see, right, we can convert a stream, we convert some data into a stream. Okay, by using its own static functions that like stream.off, or we can even go ahead and convert a list into a stream. For example, if we look at the static methods. Okay, so here if we look at, there's something called C off, right? So if we look at here, okay, we will provide a series of elements, comma separated values, to convert a stream out of that array. Okay, so similarly there are various other operations. Okay, static operations. For example, if we just want one single item and we want to convert a stream out of that, we can use it using the off. Okay, and so there are various and if we want to if we want to convert a supplier function into a stream, even that can be done using this generate function. Okay, so and if you want to concatenate two streams together, we can use a concatenation function. These are the static methods which are provided in the stream class. Okay, which can help us in creating a stream out of it. Okay, so once the stream is created or created out of the data, okay, we can use the transformation functions. Okay, and then we can apply our operations on that. Okay, so stream operations are composed of a stream pipeline. Okay, so whatever transformation functions that you want to perform, we can create it into a pipeline by attaching the methods or the operations that we need to perform. Okay, so what are the various types of operations that we can perform on the streams? we can perform intermediate operations and terminal operations. So intermediate operations are more or less operations which are um, kind of transformational, but doesn't create a specific output. There will be an output, but it doesn't terminate the stream. Okay, so the return type of an intermediate operation is further a stream, so that it could if there are any other operations that you want to perform on the stream, those can be performed downstream. And when it comes to the terminal operations is the end of the stream, where once we reach that operation, it gives a decisive output, but not a stream. Okay, it doesn't give a stream as an output. It will give a terminal decisive output out of that stream. Okay, these are the two types of operations. Now, among these two types of operations, streams are lazy. Okay, they go with the lazy evaluation. So when we say lazy evaluation, no matter how many operations we go ahead and attach to a stream, or follow it as a pipeline in the stream, okay, it doesn't evaluate or process immediately. Okay, we can stack as many streams as possible, but it doesn't evaluate them immediately. Okay, so it will evaluate them only when it sees a terminal operation. Only a terminal operation will trigger the evaluation of all the transformation functions. So till it hits a terminal operation, none of those are compiled compiled and made available, but they're not executed. So the entire pipeline will be processed or executed, okay, only when it hits a terminal operation. So this is the two different types of operations that are present in streams. Okay, now I'll show various stream operations. Okay, for example, if you see, right, this generate function, it returns a string. Of course, these are the static methods which create the string, but this is just a simple example of it. Okay, now if we go to the instance method, okay, so if we see straight example of all match or any match, okay, all match ensures that all the parameters or all the data members within that particular stream, whether they match to a predicate or not. If you have a quick if you need a quick brief of what a predicate is nothing but an um, uh, expression which returns a true or false. Okay, so if you want to know more about predicate, consumers and suppliers, you need to watch my previous videos on the lambdas. So there it is mentioned. Okay, so this all match will evaluate all the elements in the stream, and after evaluation against by following the predicate, if all of them match, then it will return a true. If any of them doesn't match, uh, then it will return a false. So in that way, it is a terminal function. So if you look at the terminal function, it is returning the boolean, not a string, right? Similarly, any match works where any of them match, and if none of them match, then it will return a false against the predicate. If none of them match, it will return a false, else it will be true, even if one of them matches. So similarly, collect will return an it will collect the data, and it will return another collection. Okay, so if we want to convert it into a collection, it will convert it to a collection and return it to us. Okay, and if we want to perform multiple operations while collecting, then we can use the collect method in here for performing those operations. So if we see here the distinct, right, distinct is a returns a string, so it's an intermediate operation. Okay, so wherever in general it returns a stream, those are intermediate operations, those are not terminal operations, because it is not going to give you a specific output. Okay, so this distinct will ensure that among all the data members that are present, okay, it will use the object dot equals object mechanism to only to only pass on the unique elements to the downstream system. To the downstream, it will create a stream of unique elements. So that's where distinct is used. So similarly, filter will apply the evaluation against a predicate, and then only when something applies successfully to that, if the predicate returns true, only then it creates a stream of those that data. Okay, and once again, find first. These are terminal operations, streams. Okay, and these are for each. Okay, for each ordered. Okay, so in this way, if we see, right, so there are quite a lot of terminal and intermediate operations. So all these operations are part of the stream API. Okay, stream class. Okay, and we can use all these methods. Okay, so that is the best part of stream pipeline and the operations. So you can traditionally, for performing these kind of operations, we had to write a lot of number of lines of code, okay, to perform these operations, right? However, with streams, the number of lines of code that we need to write reduced a lot, and this will help us in better maintaining the applications as well. How? Because these stream APIs were introduced into JDK 8 after extensive validation and verification on Oracle side, or the JDK developer side. So we can trust these streams APIs, okay, which we can use. Okay, the only thing is we need to know how we have to position the intermediate operations so that we get that desired result. Okay, so as I mentioned, the streams are lazy. Okay, computation of the source data is only performed when the terminal operation is initiated. Okay, and one more thing is, streams can be used only once. We cannot use the streams multiple times. So once we create a stream out of data and utilize it, it cannot be reused. Okay, so if you see here, a stream should be operated on only once. Okay, if we try to fork and try to utilize the same stream once again, it will throw an illegal state exception. Okay, it doesn't allow that. Okay, and the second thing is, when we take a stream and start working on that, okay, the source of the stream should not be modified. Okay, uh, because if we modify the source of the stream, then the subsequent stream operation might not behave as expected. Okay, so it might throw erroneous behavior from modifying the stream source while it is being queried. Okay, so it is always advised to take a stream, work on process it. Okay, and it is suggested not to modify the source of the stream. Okay, we can transform the stream and create it into a separate collection and then return it, but it is suggested not to modify the source of it. Okay, that is one thing. And the second one and the next one is, streams and the data that is present in streams are suggested to be immutable. For example, if we are if there is a list of objects, and we are reading those objects and performing some operation, rather than directly modifying that list as is, it is always advised to go ahead and create a new object with the data, and then return that list and use that list, rather than modifying it directly in the source. Okay, so they are immutable in that nature. They are suggested to be immutable. And subsequently, if we want to use any other parameter in any of these transformation functions, okay, which is outside the stream, then it is expected to be final. Okay, so or at least logically final. For example, if we assign data to a parameter while creation of the variable, and if we do not modify it while the stream is being used, okay, so then it is effectively final. So streams expect the external variables whichever are to be utilized in the streams, in the transformation functions in the streams, to be effectively final. Okay, so in that way, the stream behavior, okay, it doesn't it doesn't become erroneous. The primary reason for this, streams is an extension in Java for functional programming, right? So streams is introduced in the JDK itself directly as an addition and to effectively utilize the functional programming. So functions, as we know, okay, they only take an input and they produce an output, and they produce this. They have to produce the same output. Okay, for the same for the input, they should produce the same output, and the output cannot vary or change. So that's how it is pursued. So when the parameter that we are passing, okay, if the data changes, then the data that this particular function or transformation function returns might vary, right? Even though if we are following the same parameters. So that's where it is perceived to be mostly immutable, right? So that the external variables that we want to use, okay, in the streams should be immutable or final. Only then it allows. Otherwise, it will throw in a compilation exception. Okay. So this is the one. So and there is a so in this way, streams are introduced, which could be effectively used in our applications, which will reduce the number of lines of code, and at the same time, it will improve code readability, maintainability, and it will even improve predictiveness of the code. Because by looking at the code, we can immediately go through that, read through that, and then predict what this code might do. Okay. So this is about the streams and the various functions that are available in streams. Uh, Once again, streams are nothing but a stream of pipeline. Okay, stream pipeline of data, and the operations. So the operations can contain intermediate operations and terminal operations. It is advised not to modify the source while the stream is being applied on, and streams are effectively immutable. Okay, so it is not advised to modify the source data. Rather, we can create a new set of data and then return it as a collection. Okay, so and streams are lazy evaluated. That means only when it hits a terminal operation, the stream intermediate functions are executed or processed. Okay, so these are some important things that I want every one of you to memorize. Basically, especially the streams are lazy. Computation on the source data is only performed when the terminal operation is initiated, and source and elements are consumed only as needed. Okay, depending upon the intermediate operations and the output of the streams that they are going to generate. Okay, so please be this is about streams. This is the first part of it, the theoretical part of it. So the practical part of it I'll explain in the subsequent session. So please do let me know if you have any queries you can post them in the comments, so that I'll answer those in the comments or create a new video on all the bunch of questions that I receive. All right, thank you all.